Hi, I'm Mercy. I'm from the Group 10 consultancy firm, and we have been invited by Jumbo Limited to provide a solution to them concerning their current data. Jumbo Limited is a food-based organization. They are into lunch and different kind of food for students and other people. They are into catering and services. They've been in the business for the past 10 years. The business is actually a very popular one. But at the moment, Jumbo Limited, they utilizes a telesales operation that only enables them to make phone calls to their customers and gather feedback by calls, and apparently that is not enough for them to build up a good data. So that is why we have come in to advise them and send a well-to-do and a wider. Okay, so as a team of database consultancy, we have been able to come up with a system that can enable them gather data, save data, retrieve data as that's when due. And this data is going to enable, this system is going to enable them update their information, their employee information, their customer information. It's going to enable them to see everything at a glance and to be able to obtain information as at when due, especially for management decision. These are the tables we've created: customer tables and employee tables. So the customer tables, the employee tables, and the keys and the functional dependencies. So now my colleague will take us through the normalization process.
Hi, my name is Sedi and I am here for explaining about the normalization. And normalization is nothing but for each and every database creation there will be some redundancy as well as the security reasons. So normalization is nothing but it's a systematic process of organizing a database by creating tables, adding the securities to improve the data integrity. And in order to achieve a well-organized and efficient database for our client, Jomo Delighted Limited, we will be creating the first, second, and third rule of normalization form. The first normalization form, which is 1NF, and the main criteria that we are going to present is each attribute in this table must be of single value only. As you can see in the table, two tables are there. One is for customer details, and other one is for the product details, ID, orders, and everything. And here, the given attributes must be of the same data type, and it's purely unique as well. And no new tuple in this table must be designed clearly, and the order of arrangements is purely insignificant. And about the next normalization form, my colleague will be coming to present before you.
Hi, my name is Hester and I'll be taking the second and the third normalization table.
First rule of normalization must have been met, and this should not contain the partial dependency. To achieve this, we created a customer order table, product table, employee remuneration table for Jumbo Delights Limited. So this is a table, the employee relation, employee table, employee remuneration. Normalization form. After we finish with the second normalization form, we move to the third normalization form, which states that the table must be in the second normalization form and there must be no transitive dependency for non-prime attributes. So in order to meet the requirements, additional table was created for Jumbo Delights Limited. We have the customer feedback table, the customer address table, the employee address. So I'll hand over to my next colleague.
My name is Mansoor Faisal and I'm from Group 10. I'm going to present about the final normalized tables. Well, this is a final normalized table that we created with this table. We created the database in MS Access for the customer tables. And for the customer table, we have the customer feedback, customer address, and productive table, and also the customer order table. And with the customer employee table, we have the employee address and employee remuneration. And my colleague is going to present further.
Hi, my name is Silifat. I'll be taking you through the Microsoft Access files, that's database we created for Jumbo Delights, and I'll be also be showing you the forms and So these are the tables we created. We have the customer order table, this is the customer order table, the address, employee relation table, and we also created forms. This is the customer address form, which shows the postcode, house number, street name, city, region, and other customer information. We also created queries. This is the query of undelivered goods. This will be sent to the logistics department to solve the customers with undelivered orders. So we also create a list for Jumbo Delight customers that are in the Scotland region. The SQL is the SQL code for this particular query, and here is the datasheet view. So this shows that Jumbo Delight only has 2 customers in the Scotland region. This is the relationship of the tables. This relationship is well defined. It shows the relationship among all the tables that we have created. Over here is the list of all the queries we did for Jumbo Delight, and all the insert code for the tables we created. So
hi, my name is Kayan and I'm going to present the ER diagram. So in our project, we did the ER diagram by using the coursework method. And ER diagram is a visualization method which will show the relationship in between entities and the attributes. And ER model has 4 main constructs, which are basically a relationship, attributes, identifiers, and the entity. In here, our project, we have some main entities. Basically, it is customers and entities, some identifiable object that we use to build the system. As per our project, we have few entities such as customer entity, employee entity, and the product. And attributes, it's a characteristic of an entity. For an example, in employee entity, we have some specific attributes such as employee ID, first name, last name, date of hire, and the identifiers, special attributes that we use to specific instance of an entity. For that, we use to concept of foreign key and the primary key. In here, you can see the employee ID. Employee ID, it's the foreign key that we use to identify the special characteristic, and the customer ID in the customer entity, and the product ID in the product entity, and that's it.
And the last construct is the relationship. Relationship means the relationship between the entity and the attributes. In here we have customer entity and the relationship between the customer address. And one customer can have only one address. And next is order and the product table, customer order and the product table. And one order can have many products. Likewise, and we have employee table, relationship between employee table and the employee address. So one employee can have only one address.